Hello everyone, good evening. Is my voice is audible, right? Hello everyone, good evening, good evening. Is my voice is audible? Yes, we will start. So this is the last video on ODE. Right? This is the last video on ordinary differential equation where we're going to complete this chapter in this video, right? So I think it has took 27 videos. It has took 27 videos to complete ODE, right? So first we have started with solutions of differential equations of first order and first degree, and then there are many methods, right? Variable separable method, and then homogeneous differential equation, exact differential equations, and then integrating factors, right? We have seen many. So mdx plus ndy is exact when dou n by dou x is equal to dou m by dou y. Even though if it is not exact, we can make exact. I have given you 5 rules, right? There are 5 rules to make an equation exact, even though it is not exact. So these are the that is seen in solutions of differential equations of first order and first degree. After that, we have started that the second order differential equations, constant coefficients, and then Cauchy-Euler equation, Bessel's equations, and so on, right? Yes, and then Laplace transform and inverse Laplace transforms. Um, yes, and then there are that Clairaut's equations we have seen, and then equation solvable for x, solvable for y, solvable for p, and so on, right? So these are the one that we have seen in ODE. And in the last class, we have started orthogonal trajectory. This is the last topic. On the last class, we have started orthogonal trajectories. I think we have solved 4 to 5 problems in the previous class. So we'll continue with that, and then we'll wind off orthogonal trajectories in this class, and then we'll wind off ODE also, right? So first, what we will do is we will just recall what we have seen in the previous class, right? So we will just recall what we have seen in the previous class. In the previous class, we have defined what is meant by orthogonal trajectories, and then we have solved some problems in the previous class. So what I will do is I will just show you the PPT, that is the notes of previous class, what we have seen in the previous class, right? So the previous class, first we have started with what is meant by trajectories. So a curve which cuts every member of a given family of a curve is called trajectory. So if a curve cuts every member of a given family of curve, so you can see I have taken a family of curve x square plus y square is equal to a square. That is, this is the family of circles with the center 0, 0 and radius a. So if we keep on changing a, we will have different sets of circle. Now you can see this line y is equal to x cuts every member of the family of curve. So therefore this line is called trajectory. This line will be an orthogonal trajectory if it cuts at right angles, that we have discussed in the previous class, right? This is what we did in the previous class. Now how to find the orthogonal trajectory? So they will give a system of they will give a family of equation. You need to find one curve. That one curve has to cut every member in the family as well as it has to cut at right angles also. What is that curve? That is what we want to find. So how to find that curve? We need to find a curve that cuts every member in the family as well as it has to cut at right angles also. How to find that curve? There are 3 steps to find that curve. There are 3 steps to find that curve. First is differentiate the given equation of family of curves with respect to x and eliminate the parameter. That is, they will give a family of they will give an equation. Now you have to differentiate with respect to x. After that, you need to eliminate the parameter, right? A parameter, right? Yes. Now after that you have to replace dy by dx by minus dx by dy, dy by dx by minus dx by dy. After that you will have a differential equation. Solve the differential equation to get the orthogonal trajectory. See, this we have done in the previous class. I'm just recalling you, right? So we have done with the first problem, and then we have done the second problem. We have done with third problem. So you can see the first problem, right? So differentiate this with respect to x. I have done. We have to eliminate the parameter. That is, here a is the parameter, right? If I keeps on changing a, you will get different family of circles. Different family of circles. Now, because this is equation of circle, I think, right? In general form, x square plus y square plus 2gx plus 2fy plus e is equal to 0. So I have taken this as equation number 1, and I have differentiated with respect to x. So I have got this. Now after that you have to eliminate a. So we have a here, right? So you can find a in terms of x and y, and you can substitute back here. After that you have to replace dy by dx by minus dx by dy. You will have a differential equation. Solve that differential equation to get the orthogonal trajectory. Right? This is what we did in the previous class. So if you haven't watched the previous class, please watch previous class. Go watching this class, right? And then we have solved third problem, we have solved fourth problem, we have solved fifth problem, we have solved sixth problem also. Now we will start with seventh problem, right? So I think we have solved six problems as of now. So what I will do is I will do two more problems, seventh and eighth, right? I will do two more problems, seventh and eighth. You can see all these are in Cartesian form. After doing two more problems in Cartesian form, we will find the orthogonal trajectory in polar form, right? So we will wind off everything today. I'm going to do two problems in Cartesian form, and then I'm going to tell you the working rule to find the orthogonal trajectory for polar coordinates. That is in polar form. Then we will solve four problems based on, right? Overall, we're going to solve six problems today. Two problems on these sets, and the other four problems based on polar form, right? Okay, you just recall what we have to do. So we have to differentiate this with respect to x, eliminate the parameter. After eliminating the parameter, replace dy by dx by minus dx by dy. You will have one differential equation. Find the solution of differential equation. You know how to solve differential equation, right? You can use variable separable. Sorry, you can use variable separable or homogeneous or integrating factors, or you can use in the previous classes we have given you the set of methods to solve differential equation, right? You just see which case it falls under, and then you do it, right? Yes. So we will start with the problem. Yes. So we have done six problems in the previous class. So we will start with the seventh problem today, right? Yes. So this is continuation of previous class. So I'll just put seventh problem here. So find the differential equation. Sorry, find the orthogonal trajectory. Find the orthogonal trajectory. Find the orthogonal trajectory of family of circles passing through find the orthogonal trajectory of family of circles passing through 0 comma 2 and 0 comma minus 2. In the previous six problems, they have given you the equation directly, right? The previous six problems, they have given you, they have given you, see, these are all P by Qs only, right? Fazil Rahman, this is a P by Q. And in the previous class, we have solved the six problems, right? In those two problems are P by Q. I'm not mentioning that it is P by Q, right? You just go through it and then you see P by Q, you can able to do. This is also a P by Q, but I'm not mentioning. This is 2022, I think, 2022 or 2020. 2022 or 2020, just check it out. This is a PYQ. Okay, so in the all six problems, in the previous problems, they were given you the equation directly, but here they haven't given you the equation directly. So first you need to find a equation of family of circles that passing through these 2 points. After that you need to do the working rule, right? Okay, so what they have given is, so we have it should pass through 0 comma 2 and 0 comma minus 2, right? So there are many circles, right? there will be many circles that are passing through this point, right? There will be many circles that will be passing through this point, right? So there are many circles that will pass through these 2 points. So first what we will do is we will find the equation of family of circles passing through these 2 points. After that we will find the orthogonal trajectory. So I'll give you, I'll tell you the formula now. So you just remember equation of family of circles, equation of family of circles passing through 2 points, passing through x1 comma y1 and x2 comma y2. So what is the equation of family of circle that is passing through these 2 points? I'll give you the formula. So the formula is given by x minus x1, x minus x1, x minus x2 plus y minus y1, y minus y2 plus lambda times y minus y1 into x2 minus x1 minus x minus x1 y2 minus y1. You just remember this formula around. This is the equation of family of circles that is passing through two given point, right? Remember this formula, very important formula. So in exam point of view, even whatever 2 point they may give, right? In exam point of view, whatever 2 point you may give, they may give. You just remember the formula, equation of family of circle passing through 2 point is given by this formula. So here the 2 points are, this is our x1 y1 and this is our x2 y2, right? So we just substitute here, right? So instead of x1 y1, instead of x2 y2, we substitute these 4 points. I'm not going to do that, right? You will have an equation. Substitute 0 comma 2 and 0 comma minus 2, right? This is our x1 y1, this is our x2 y2. So you will have, I have already done, I'm not going to do that. You will have x square plus y square plus 4 lambda x minus 4 is equal to 0. Is the required is the required family of circle. Is the required family the required family, right? So just substitute x1 y1 to be 0 comma 2 and x2 y2 to be 0 comma minus 2 in this equation. You will have this equation, right? So in all 6 problems they will give they will be given, the question will be like this, right? Find the family of find the orthogonal trajectory of family of circle, x square plus y square plus 4 lambda x minus 4 is equal to 0, where lambda is a parameter here, right? But here they have given you it has to pass through these 2, right? But remember this formula. In this formula, you substitute these 2, you will have this. Now we will do as usual, right? So we have x square plus y square. I'll do this is fast, very easy problem. Plus 4 lambda x plus 4 lambda x minus 4 is equal to 0, right? Okay, call this as equation number 1. So differentiate with respect to x and eliminate the parameter. This is the first step, right? Differentiate with respect to x and eliminate the parameter. So differentiate with respect to x. So we will have 2x plus 2y dy by dx, 2y dy by dx plus 4 lambda is equal to 0, right? So derivative of x is 1, derivative of y square is 2y dy by dx, right? 2y dy by dx. Okay, now we need to eliminate the parameter here, so we'll do that. So from here we have, so I can write this as x plus y dy by dx plus 2 lambda is equal to 0, right? I'm just taking 2 outside, dividing by 2, right? And we have 2 minus 2 lambda is equal to x plus y into dy by dx. So the lambda value is minus 1 by 2 x plus y into dy by dx. Our aim is to eliminate the parameter lambda, right? Now what I can do is this, what we will be doing in all 6 problems, the previous problems, right? This is what we have done in all previous problems. Now differentiate with respect to x. So again, what I'm going to do is I'm going to replace this lambda here. So if I replace this lambda here, I can eliminate the parameter, right? So from 1 we have, from 1 we have x square plus y square plus 4 lambda x minus 4 is equal to 0. Now instead of lambda, I'm going to substitute this value. So we have x square plus y square plus 4x. Instead of lambda, I'm going to do minus 1 by 2 x plus y dy by dx is equal to 4, right? I'm just taking this term to that side. Now this 2 ones are 2 2s are will get cancelled. So we have x square plus y square minus 2x x plus y dy by dx is equal to 4, right? X plus y dy by dx is equal to 4. X square plus y square minus 2x x plus y dy by dx is equal to 4. Now we will multiply this 2x inside. So we have x square plus y square. So you can see minus 2x square minus 2xy dy by dx. So minus 2x square minus 2xy dy by dx is equal to 4. As of now, very simple, right? So we are only in first step. So we have differentiated with respect to x and then we have eliminated the parameter. We will simplify this. After that, we will replace dy by dx by minus dx by dy. So x square minus y square. X square minus 2x square is minus x square. Let's take this minus 4 to that side. Is equal to 2xy dy by dx, right? So we are done with first step. So what is the second step? Replace dy by dx by minus dx by dy. So if I do that, we will have y square minus x square minus 4 is equal to 2xy. So instead of dy by dx, I'm replacing that by minus dx by dy, right? So we'll cross multiply. So if we cross multiply, we will have 2xy dx plus y square minus x square minus 4 dy is equal to 0. So I can see it is of the form mdx plus ndy is equal to 0, right? But it is not exact. So it is of the form mdx plus ndy is equal to 0. Is of the form mdx plus ndy is equal to 0. If it is exact means we know solution, right? Integration of y constant mdx plus integration of terms in n not containing x dy is equal to c. We know the solution of exact differential equation. We have already done this before. But here it is not exact, right? So what is dou n by dou x? What is dou n by dou x? So this is our mdx, and this is our n. So mdx n dy. So dou n by dou x is minus 2x. And what about dou m by dou y with respect to y? It is 2x. So you can see these two are not equal, right? It is minus 2x and it is plus 2x. So here you can see dou n by dou x is not equal to dou m by dou y. It is not exact, but we can change this to exact if it falls under any one of the rule. We have seen 5 rules, right? Now you can see this falls under rule 4. This falls under rule 4. Rule 4, right? Rule 4. You just recall, right? So you just recall the rule 4 of how to convert, even though if it is not exact differential equation, we can convert that to exact if it. I have given you 5 rules when we are solving those. So what rule 4 says is, if dou n by dou x, if dou n by dou x minus dou m by dou y divided by m is a function of y only, right? Is a function of y only, then e power integration of f of y dy is an integrating factor. This is our rule 4, right? You just have to watch all the previous videos, then it will be very easy. See, we are just needed to solve this equation, that's it. So we can solve this by rule 4 of exact differential equation. Now whether we see whether it satisfies rule 4 or not. Now what is dou n by dou x? It is minus 2x minus dou m by dou y. Dou m by dou y is again 2x. Dou n by dou x is minus 2x minus dou m by dou y is 2x divided by m. So what is m? M is 2xy. This is minus 4x divided by 2xy. 2 ones are 2 twos are. So we will have minus 2 by y, which is a function of y only, right? So it falls under rule 4. So that means e power f of y is an integrating factor. This implies e power integration of f of y dy is an integrating factor. So e power integration of what is our f of y? Minus 2 by y dy is an integrating factor. So e power minus 2 integration of 1 by y dy is log y. This is e power log y power minus 2. So 1 by y square is our integrating factor. That is, this is a not exact, but if you multiply 1 by y square throughout the equation, it will become exact. That is what we know, right? That is what we know, right? So it is not, this equation is not exact, right? Let us call this as star. But if I multiply by 1 by y square throughout, this will be exact. So in multiply star by 1 by y square, this will be exact now, right? So 2xy, so 1 by y square 2xy dx. So m dx plus n dy. So I'm just multiplying 1 by y square throughout so that it will become exact now. Y square minus x square minus 4. Now it will be exact. You can check it out that dou n by dou x will be same as dou m by dou y. Is it clear? See, these are very elementary that we did in the previous class, right? So it is not exact. If I multiply throughout by an integrating factor, it will be exact. It falls under rule 4. So rule 4 by integrating factor is 1 by y square. So multiply throughout by 1 by y square. Now this is exact, right? Now this will be exact. And check it out. Now this will be exact. Now this will be exact. You can check it out that dou n by dou x will be same as dou m by dou y. So since it is exact, what is the solution? The solution is, so what is the solution of exact differential equation? Integration of m dx. You need to integrate by treating y as a constant. Integration of m dx plus integration of terms in n not containing x, not containing x into dy is equal to c. This is a solution of exact differential equation, right? So integration of m dx. So what is our m now? This is our new m, right? This is our new m. So 1 by y square 2xy. So 1 by y square 2xy. This is our m now. So integration of m dx. You need to integrate by treating y as a constant. Y as a constant plus integration of terms in n not containing x. So you can see if I multiply y square, here we will have 1. So 1 will not contain x. And if I multiply this inside, we will have, so we have three terms here, right? We have three terms. 1 minus x square by y square minus 4 by y square. So these are the three terms you will have after multiplying y square. So these terms contain x, so cancel it out. So there are two terms that does not contain x. What are those two terms? 1 minus 4 by y square. 1 minus 4 by y square into dy is equal to c, right? Terms in n not containing x. There are three terms in n. This term containing x, cancel it out. So 1 minus 4 by y square. So this will be, so y will get cancelled. So just take this, just take 2 by y outside, right? You need to integrate by treating y as a constant. So we have 2 by y integration of, so 2 by y integration of x dx. So integration of y is integration of dy minus 4 times integration of y power minus 2 dy is equal to c. So 2 by y x square by 2 plus y minus 4 times y power minus 1 by minus 1 is equal to c. So x square by y plus y plus 4 by y is equal to c is the required solution. Can you move on to the next problem? Is it clear? Is it clear? Very simple, right? You just have to find the solution of differential equation. It falls under exact differential equation. We move on to the next problem. The eighth problem is find the orthogonal trajectory find the orthogonal trajectory of y square is equal to 4a into x plus a. This is a parabola, right? So, okay, you need to find the is there any doubt? Okay, so find the orthogonal trajectory of this curve. Okay, so we have y square is equal to 4a into x plus a. Call this as equation number 1. So differentiate with respect, here a is a parameter, right? So differentiate with respect to x, differentiate with respect to x, and then we need to eliminate the parameter. But first we will do this. So we have 2y dy by dx, so 4a 1, right? Okay. So y square is equal to 4 2y dy by dx 4a 1 plus a. So what we can do is, so we need to eliminate parameter, right? So put 2 in 1. That is, in place of 4a, you just substitute 4a to be 2y dy by dx, right? So we have y square is equal to 4a x plus a. This is our equation number 1. So instead of 4a, I am going to write 2y dy by dx into x plus a. The question correct? Y square is equal to y square is equal to 4a x plus a. Yes, correct only. Okay, what we can do is, okay, here also we have a, right? Okay, so what we will do is, see, we need to eliminate parameter. So we have eliminated one parameter, but here we have one more parameter here, right? What we will do is we will find a here, right? Instead of 4a, we will find a here, so that I can replace here and here. Okay, I think you're getting my point, right? I'm finding 4a and I'm replacing 4a to be 2a d by dx. But again, we have a here. We need to eliminate all the parameters, right? Yes, so what we will do is, so instead of finding 4a, we will find a. So instead of finding 4a, we will find a. So 2y, right? And 1, 2a. So we have y dy by dx is equal to 2a. So a value is y by 2 dy by dx, right? A value is y by 2 dy by dx. Call this as equation number 2. Now here what we can do is we can replace a to be y by 2 dy by dx, right? So that we will be eliminating the parameter. So from 1 we have y square is equal to 4a x plus a. So instead of a, I'm going to replace y by 2 dy by dx. So 4a. So a is y by 2 dy by dx. A is y by 2 dy by dx, right? So what we have is y square is equal to, so 2y dy by dx x plus y by 2 dy by dx, right? Now we'll multiply this 2y dy by dx inside. We'll multiply this inside. We will have So we have y square is equal to 2xy dy by dx. And if I multiply this 2y here, 2 will get cancelled, right? So we will have y square dy by dx, right? If I multiply this inside, this 2 will get cancelled, y square dy by dx, right? So this is a very, very important problem. Just listen carefully, right? Call this as star. Now we have to we are done with step 1, right? So step 1 is differential with respect to x, eliminate the parameter, we are done. Now what is step 2 is you have to replace dy by dx by minus dx by dy, right? Minus dx by dy. So we will have y square 2xy. So instead of dy by dx, I am replacing minus dx by dy, y square instead of dy by d. Okay, I think we will have dy by dx whole square here, right? See, when you multiply this inside, dy by dx, dy by dx, it will be dy by dx whole square. 2 will get cancelled. So y square dy by dx whole square. Right? So we have replaced dy by dx by minus dx by dy. Very simple, right? So dy by dx minus dx by dy minus dx by dy. Now y square is equal to 2xy. Now I'm going to write this dx by dy as I'm going to write this as dy by dx. Right? And here I will have y square. I'm going to write this as dy by dx whole square. Both are same only, right? So let us keep this minus aside. I'm writing dx by dy as dy by dx divided by this dy by dx whole square, right? I'm going to take LCM now. So what is the LCM here? I'm going to multiply dy by dx here, dy by dx here. So if I multiply dy by dx here, so we have y square dy by dx whole square, right? I'm just taking LCM here and then I'm multiplying here, right? So I have to multiply dy by dx, dy by dx. So we have minus 2xy dy by dx plus y square. Is this step is clear? See, I'm just multiplying dy by dx, dy by dx, right? After that, we will have minus 2xy dy by dx plus y square will remain as it is. Here LCM is dy by dx whole square. So we have dy by dx whole square common, multiply this side, so you will have this, right? Now, let us take this term to that side. So we have y square is equal to 2xy dy by dx plus y square dy by dx whole square. See, what we are getting after replacing dy by dx by minus dx by dy, we are getting the same equation, yes or no? This is the equation that we have already. After replacing dy by dx by minus dx by dy, again we are getting the same equation. If that happens, we say it is self-orthogonal. We say it is self-orthogonal, right? We say it is a self-orthogonal. That means the orthogonal trajectory for the system is same. That is y square is equal to 4a into x plus a, right? So from star and double star, it is self orthogonal. That is, it belongs to the same system. It belongs to the same system, right? The orthogonal trajectory is the same equation as given in the question. Y square is equal to 4a to x plus a. Very important. In exam point of view, they will say prove that it is self orthogonal. Prove that it belongs to the same system. That means You have to say after replacing dy by dx by minus dx by dy, if you are getting the same equation, then it is meant that it is self orthogonal, right? That means it belongs to the same system. The given question is the orthogonal trajectory. So very easy in exam point of view. If they ask, so you just differentiate with respect to x, eliminate parameter, you will have an equation. Replace dy by dx minus dx by dy. Try to bring out the same equation. If these two are same, if the question itself they will give, prove that it is self, prove that this belongs to the same system. That is, prove that the orthogonal trajectory of this family belongs to the same system. In that case, you need to prove this. Very, very easy. You know what to prove, right? So you just have to replace dy by dx minus dx by dy and try to bring out the same equation so that you can say it belongs to the same system. Is it clear? Is it clear? Is it clear? Can you move on to next problems? In exam point of view, if they say prove that it is self orthogonal and prove that both belongs to same system, means you have to do like this. Okay, so we are done with orthogonal trajectory for Cartesians. Now we'll move on to polar coordinates, right? So how to find the orthogonal trajectory if it is polar form, right? That is the next subtopic. And the last, I will give you an exercise problem. So we have done 8 problems, right? Okay. So orthogonal trajectory in polar form. So we're going to do 4 problems now. We're going to do 4 problems now. Okay. So again, the working rule is same, right? So in that working rule, we have the first step is differentiate with respect to x and eliminate theta. So here the working rule will be slightly different. So differentiate with respect to theta, right? There we will differentiate with respect to x. So here you differentiate with respect to theta and eliminate the parameter, right? There you will differentiate with respect to x and then you will eliminate parameter. Here it is different to theta. Now second is replace dr by d theta by minus r square d theta by dr. There we will replace du by dx as minus dx by dy. So here you have to replace dr by d theta by minus r square d theta by r. Solve the differential equation to get required orthogonal trajectory. To get required orthogonal trajectory. Right? Very simple. So we'll do 4 problems based on this, right? So just compare and study. It will be very easy for you. Okay. So differentiate with respect to theta. Eliminate the parameter. Replace dr by d theta by minus r square d theta by dr and solve the differential equation to get the required orthogonal trajectory. Okay. So we'll move on to first problem. We're going to do 4 problems and then wind off. Find the orthogonal trajectory of r is equal to a into, that is, it is a cardioid, right? R into a into 1 minus cos theta. This is a family of cardioids. Find the orthogonal trajectory where A is a parameter. See, it is in polar form, right? In terms of r and theta. In terms of r and theta. So we will do this again, very easy problem. So we have r is equal to a into 1 plus 1 minus or 1 plus. It is minus. So 1 minus cos theta. So differentiate with respect to theta and then eliminate the parameter. Differentiate with respect to theta. So we have dr by d theta is equal to a into 0. Derivative of cos theta is minus sin theta. So we have dr by d theta is equal to a sin theta. Right. Now we need to eliminate parameter. So from here I can find the value of a, right? So a is 1 by sin theta dr by d theta. So substitute back in 1. So 1 is r is equal to a into 1 minus cos theta. So instead of a, I am going to substitute here. So 1 by sin theta dr by d theta 1 minus cos theta. So we have multiply this inside. So okay, let us keep this as it is, right? R is equal to 1 minus cos theta by sin theta dr by d theta, right? Okay. We are done with first step, right? We have eliminated the parameter. So differentiate with respect to theta. So I'm finding a here in terms of r and theta. I replace that. So we are eliminating the parameter. We are done with step 1. So what is step 2? Replace dr by d theta by minus r square d theta by dr minus r square d theta by dr. So we will have r is equal to 1 minus cos theta by sin theta. So instead of this dr by d theta, I am replacing minus r square d theta by dr. Okay, so what is 1 minus cos theta? It is 2 sin square theta by 2. And this is 2 sin theta by 2 cos theta by 2. Right? These are very elementary formulas. So sin 2 theta is 2 sin theta cos theta. Right? We know sin 2 theta is 2 sin theta cos theta. So sin theta will be 2 sin theta by 2 cos theta by 2. And 1 minus cos theta is 2 sin square theta by 2. Very important formula all this. So 2 will get cancelled. 1 sin will get cancelled. So we will have, so you will have sin will get cancelled, right? Sin by cos. So we will have tan theta by 2. Here we have r and here we have r and here we have minus r square d theta by dr. So one r will get cancelled. So we have minus r here. So we have minus r here. So we have dr by r minus tan theta by 2 d theta, right? So separate the variables. So bring this dr, bring this r down. So we have dr by r. Let us keep this minus here. Integration of tan theta by 2. Now integrate, right? So you can see the variables are separated, right? You can see the variables are separated. This is log r. So integration of minus tan theta by 2 will be integration of tan theta by 2 is minus log sin theta by 2 divided by integration of this theta by 2 is 1, differentiation of this theta by 2 is 1 by 2, right? Integration of tan theta by 2 is minus log sin theta by 2. Very easy, right? What is integration of tan x? Integration of, I can write tan x by sin x by cos x. So integration of f of x by f dash of x. It is log f, sorry, integration of f dash of x by f of x is log f of x, right? So if I can use that, see. So we know that integration of tan x is integration of, this is same as, sorry, this is same as sin x by cos x So let us multiply minus minus, so that derivative of cos x minus sin x. Right? Let us multiply minus minus. So we will have minus minus. So log of cos x, right? Sorry, log of cos x. Sorry, it is log of cos theta by 2. Right? So integration of tan x is, I can write minus minus sin x by cos x. So cos x derivative is minus sin x. So it is minus log cos x, right? So it is minus log cos theta by 2. Differentiate this theta by 2, you will have c. Let's add some integration constant log c. So we will have log r is equal to so minus minus will get cancelled. So 2 log cos theta by 2, 2 log cos theta by 2 by 1 by plus log c. So this is, take this to numerator. So this is log of, so log a plus log b cos square theta by 2 into c. So this log will get cancelled. So we have r is equal to c times cos square theta by 2. This is a required answer, right? If you want, you can also use cos square theta is 1 plus cos 2 theta by 2. You can also use that, or will leave. This is the required orthogonal trajectory. Is it clear? Okay. Or you can also use the formula r is equal to c into, so cos square theta is 1 plus cos 2 theta by 2. So 1 plus cos 2 theta by 2. So here theta is theta by 2. So c into 1 plus cos theta by 2. So both are same only, right? 1 plus cos theta by 2. This is a required orthogonal trajectory. So very simple. You just have to differentiate with respect to theta, eliminate the parameter, and then you replace dr by d theta as minus r square d theta by dr. Integrate, you get the answer. On second problem. To find the orthogonal trajectory of r is equal to, sorry, a is equal to r square cos theta. R is equal to a square cos theta. So we have a is equal to r square cos theta. Call this as equation number 1. So differentiate with respect to theta and then eliminate the parameter. So differentiate with respect to theta. This is a, right? This is 0. So let us multiply u, 2r dr by d theta cos theta plus r square derivative of cos theta is minus sin theta, right? I'm just applying product rule. R square cos theta, differentiate this, differentiate this. Okay. Here a is our parameter, right? We need to eliminate a. Okay. I think we have eliminated a from here itself, right? We have eliminated a here itself, right? Because derivative a is not here, right? We don't need to eliminate a now. Differentiation itself, a is eliminated. Okay. So we have 2r dr by d theta cos theta is equal to r square sin theta, right? Is equal to r square sin theta. Is it clear? Or a is equal to r square cos 2 theta, right? Okay. So this r will get cancelled. One r will get cancelled. So 2 cos theta. So 2 times cos theta dr by d theta is equal to r sin theta, right? Okay. Now we have to replace this dr by d theta as minus r square d theta by dr. So this will be 2 times cos theta minus r square d theta by dr is equal to r sin theta, right? Is equal to r sin theta. So again this 1r and 1r will get cancelled. So we will have minus 2r cos theta d theta by dr is equal to sin theta. So what we can do is, let's bring the sin theta here. So we will have cos theta by sin theta d theta. Take this dr r to this side. We have dr by r, right? Variables are separated, right? Theta and r are variables here. So cos theta d theta sin theta dr by r, right? Yes. Minus 2 times cos theta. Okay. So we integrate this. Integrate this. This is what? Sin theta integration of f dash of x by, we know integration of f dash by f is log f, right? So sin theta derivative is cos theta. So minus 2 times log of sin theta. This is log r plus log c, right? So I can take this minus 2 to the power. So that means it will be 1 by sin square theta, right? So log of, take this minus 2 to the power. So we will have sin power minus 2 theta, which is 1 by sin square theta. This is log RC. So RC is equal to 1 by sin square theta is the required orthogonal trajectory. Is the required orthogonal trajectory, right? Very easy, right? Can we move on to the next problem? Okay, Shivanshu Sharma, can you please join Telegram group? I have given you the updates there. Okay, so we'll move on to third problem. Two more problems. We'll be winding up this topic. To find the orthogonal trajectory, of r square is equal to a square cos 2 theta. Okay, so we'll do this. So we have r square is equal to a square cos 2 theta. So differentiate with respect to theta. Differentiate with respect to theta. So we will have 2r dr by d theta a square derivative of cos 2 theta is minus sin 2 theta into 2, right? And differentiating this, minus sin 2 theta into 2. Okay, 2 will get cancelled. So we have r dr by d theta is minus a square sin 2 theta. So that means I can find the value of a square from here. So a square is minus r by sin 2 theta dr by d theta, right? A square is minus r by sine 2 theta dr by d theta. Substitute in 1, you can eliminate the parameter. So 1 we have r square is equal to a square cos 2 theta. So instead of a square, I'm going to write minus r by sine 2 theta dr by d theta into cos 2 theta. Right? I've just replaced a square by minus r by sine 2 theta dr by d theta. Okay, so again this one r will get cancelled. So we have r is equal to minus cos 2 theta by sine 2 theta dr by d theta, right? Minus cos 2 theta by sine 2 theta dr by d theta. Now replace dr by d theta by minus r square d theta by dr minus r square d theta by dr, right? So we will have r is equal to minus cos 2 theta by sine 2 theta. So instead of dr by d theta, I'm replacing minus r square d theta by dr, right? Okay. So one r will get cancelled. Minus minus will be plus. So we have 1 is equal to cos 2 theta by sine 2 theta. We will have 1 r d theta by dr. Let us bring this dr by r. This is cos 2 theta sine 2 theta d theta, right? Okay. So integrate this, right? Integrate this. So differentiation of sine 2 theta is cos 2 theta into 2. So but 2 is missing here. So we will multiply into 2 into 2. Divide multiply divide by 2. Now you can use the formula sine 2 theta derivative is cos 2 theta into 2. This is log r. This is 1 by 2 log sine 2 theta plus some constant log c, right? See, derivative sine 2 theta, its derivative is 2 cos 2 theta. So that means this is log sine 2 theta. So this take this 1 by 2 to here. We will have log of root sine 2 theta plus log c. Here we will have log r. That means r is equal to c root sine 2 theta, right? This is the required answer. R is equal to c root sine 2 theta. This is the required orthogonal trajectory, right? Okay. So we'll move on to last problem and then we'll wind up this topic. Um, Last problem is find the orthogonal trajectory of r is equal to 2a sine theta plus cos theta. Where a is a parameter. Right? So we'll do this and then we'll wind up. So we have r is equal to 2a sine theta plus cos theta. All this is equation number 1. So differentiate with respect to theta. So we have dr by d theta 2a. Derivative of sine theta is cos theta. This is minus sine theta. Right? So I can find the value of 2a from here. So 2a is 1 divided by cos theta minus sin theta dr by d theta, right? So we can eliminate the parameter easily. So substitute 2 in 1, you can eliminate the parameter. So put 2 in 1. So from 1 we have r is equal to 2a sin theta plus cos theta. So instead of 2a, I'm going to write 1 by cos theta minus sin theta dr by d theta sin theta plus cos theta. So we have r is equal to sin theta plus cos theta divided by cos theta minus sin theta dr by d theta, right? So replace replace dr by d theta as minus r square d theta by dr. So this will become r is equal to sin theta plus cos theta divided by cos theta minus sin theta dr by d theta is minus r square d theta by dr, right? So this r and one r will get cancelled. Let's multiply this minus here. So we have dr by r, right? Dr by r minus sin theta minus cos theta divided by cos theta minus sin theta d theta, right? I've just multiplied this minus sin theta minus cos theta, and then I have replaced, I've taken this dr by r. Now integrate this log r. See, cos theta derivative is minus sin theta, sin theta derivative is cos theta. So integration of f dash by f, right? So if I differentiate cos theta minus sin theta, we will have minus sin theta minus cos theta. So I can write this as log of cos theta minus sin theta. Let us add some constant log c. That means r is equal to c into cos theta minus sin theta. So as you can see, log a plus log b is log ab. Log will get cancelled. Is the required solution. That's it. So we are done with orthogonal trajectory. Yes, I'll give you one more exercise problem. You can do that. Um, you can do that. So find the orthogonal trajectory of the family of curve. If it is not visible, I'll just send you the notes in Telegram. So what it says is find the orthogonal trajectory of the curve x square by a square plus lambda, y square by b square plus lambda is equal to 1. Very important problem. Actually, first you have to differentiate with respect to x, eliminate parameter. After eliminating parameter, you have to replace dy by dx by minus dx by dy. You'll be getting the same one, right? So which is differential equation of family 1. After differentiating with respect to x and replacing dy by dx by minus dx by dy, you will have the same equation, right? You will have the same equation. That means what? It is self-orthogonal, right? It is self-orthogonal. That means it belongs to the same system, right? Hence the system of the given curve is self-orthogonal, right? So we have already done one problem with self-orthogonal, right? We have done one problem, right? Y square is equal to from parabola. This is also same problem. So find the, in exam point of view, they will say show that the system of confocal conics is self-orthogonal. Very important problem. You need to prove self-orthogonal. Very easy, right? X square by a square plus lambda plus y square by b square plus lambda is equal to 1 is self-orthogonal. Means differentiate, eliminate parameter, replace dy by dx by minus dx by dy, you will get the same equation, right? You will get the same equation. That means it is self-orthogonal, right? Yes. It's a very easy problem. You can do this very easily, right? Yes. See. This is a question. Differentiate with respect to x. We already done one problem, right? Differentiate with respect to x. You bring dy by dx is equal to something. Now replace that. You get the again same equation. That means it is self-orthogonal, right? So I will finish off differential equations. That is ODE. Um, so thank you for the patience. It took almost 27 videos. Thank you for your patience. So we will start analytical geometry from next class. We will start analytical geometry from next class. So go through all the videos, take proper notes, solve PYQs. I think you can do PYQs also. I'll give some practice problems also. So thank you. Successfully we have done with ODE. The next class we will see with new topic. Right? Thank you. All the best.